Oftentimes we're faced with having to work with extremely large numbers. For example, how many grains of sand are there on a square mile of beach? Maybe that's how many there are. They also have to work with, or we also have to work with extremely tiny numbers. For example, what's the diameter of an atom in centimeters? Again, I have no idea whether that's right or not, but that certainly is a little number. And performing calculations with either really, really big numbers or really, really little numbers is difficult and cumbersome and burdensome. And so scientists, along with some friendly mathematicians, came up with a method called scientific notation for transforming these extremely large or extremely small numbers into a much more manageable form, scientific notation. And that's what this lesson will deal with. We'll look at how to change any number into scientific notation. In scientific notation, we will take all numbers or any numbers and break them into two factors. Remember, I've used the word factor in many of my lessons, and I think of a factor as being something connected to something else by multiplication. There are criteria we have to follow, however. We can't just put anything in these blanks. And the criteria for the first factor is that our number must be greater than or equal to 1, but also less than 10. Our second factor must be a power of 10. Now, what are our powers of 10? Let's do a quick review of that. We know that 10 to the 0, at least I hope we know, is 1. 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. And I'm sure your teacher has shown you the trick for powers of 10. We have as many zeros as the exponent on the 10. So 10 to the 7th power would be a 1 with 1, 2, 3, 4, 5, 6, 7 zeros, or 10 million. Okay? So again, in scientific notation, our first factor will be a decimal number greater than or equal to 1, but also less than 10, connected to some power of 10 by multiplication. Let's look at an example of a very large number and how we would transform that into scientific notation. Let's take that number we had up on the board a few moments ago, and I'm not sure I'm going to get it exactly the same, but I remember it was an 18 with a whole bunch of zeros. So let's take that number right there. Okay? I hope you'd agree that's a gigantic number. Happens to be what? 1,800,000,000. Almost made a mistake there myself. We know that in a whole number, which this is, the decimal point is over there. We don't bother writing it, but we know that that's where it is if we need to find it. Now remember, our first factor is going to be a decimal number that's greater than or equal to 1, but less than 10. And it must obviously be some of these numbers, because this is the number we're going to transform. Well, in order to create that decimal point number, we're going to have to move this decimal in this direction until we arrive at a space that creates a decimal number that fits those criteria. If we move it, move it, move it, move it. What if we put it right there? Well, that would give us 18. And 18 is greater than or equal to 1, but it's not less than 10, is it? So it can't go there. Obviously, the only place it could go would be right between the 1 and the 8. That would create the decimal number 1.8. And that's going to be our first factor in scientific notation. Then comes a multiplication symbol. Remember what our second factor is? It's a power of 10. Now this is where it gets easy. In order to determine the power, all we have to do is count how many places it took to get the decimal point from there all the way over to here. 1, 2, 3, 4, 5, 6, 7, 8. It took 9 jumps, and therefore our power is 9. Couldn't be easier. And so 1,800,000,000 in scientific notation would be written as 1.8 times 10 to the 9th power. Okay? Let's try another. How about 5, 5, 5, 0, 0, 0, 0, 0. Okay? Let's see if we can do it without blanks this time. We need to move the decimal point from here in this direction until we get it to a place in which the number is greater than or equal to 1, but less than 10. That's right. It's got to go right between the first two 5s, because that would give us the decimal point number 5.55. So that's our first factor. Times 10. Again, what did we do? We moved the decimal point from here 1, 2, 3, 4, 5, 6, 7 places, and so our exponent is 7. 5.55 times 10 to the 7th power. So making a large number and putting it into scientific notation is really no harder than counting. Let's see what we have to do to change a little number into scientific notation. Remember that little numbers begin with the decimal point and then usually a whole bunch of zeros until finally we get to some significant digits way over here on the right end. Let's see if I can remember how our decimal places work. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths. And so this number is 46 100 millionths. That's a very tiny number. Well, the rule or the criteria is exactly the same. We need to move this decimal point in this direction until we create a number that's bigger than 1 but less than 10. What if we put the decimal point right there in front of the 4? Well, that wouldn't work, would it? Because that would be 0.46, and that's less than 1. So I guess the only place we can put that decimal is right between the 4 and the 6, which will give us a first factor of 4.6. Certainly that's greater than or equal to 1 and less than 10. Multiplication symbol, 10, and now the power. Well, if you remember when we changed the big numbers to scientific notation, the decimal point was over here, and we moved it this direction. Just the opposite is true this time, where the decimal point started over here, and we're going in that direction. In order to show that, we are going to use a negative exponent. We're still going to count exactly the same way, but instead of using a positive exponent, which makes a number bigger, we're going to use a negative exponent, which makes the number smaller. Count in exactly the same way. 1 place, 2 place, 3, 4, 5, 6. We moved it 7 places, and so we're going to make this negative 7. 4.6 times 10 to the negative 7. Let's try one more small number, and then we'll end this lesson. Let's say 0.0000000105. Let's just think about these digits over here. Where's the decimal point have to go? That's correct. It's got to go between the 1 and the 0. If it went there, it would be 10.5. If it went there, it would be 105. If it went there, it would be 0.105. So the criteria say it's got to be greater than or equal to 1. That's the only place to put the decimal. So 1.05 times 10. Remember now, negative exponent. 1, 2, 3, 4, 5, 6, 7. Again, 10 to the negative 7. 1.05 times 10 to the negative 7 is this number in scientific notation.